Hi, this is ABC, and today I'm going to discuss about what is data engineering, my journey around data engineering, how I moved from software engineering to data engineering, what is the current definition of data engineering, current technology and landscape of data engineering, and finally the entry bar. What is the entry bar for junior, fresher, and then intermediate, senior, staff principal? So it all depends what kinds of skill set you need in the form of data engineering. So data engineering for me is software engineering on data. I mean, that is what I always say, and I believe it is a derivative of software engineering, and we just emphasize in this particular tech stack to work around data because this particular problem definition is complicated. It has many different dimensions to work with. So, like front end engineer, back end engineer, there is data engineer. But finally, it's all coming from software engineer as well. Uh, we suddenly had a lot of data, and we were actually engineering everything based on threads. So it was completely on Java, and we were writing concurrent programming, trying to understand deadlock and writing semaphore and many those concurrent thread programming and to finally getting a parallelization over a CPU and trying to handle quite a lot of data. Then first time I interacted with Hadoop, I it was actually I was in Bangalore and I met in our office premise some engineers from Yahoo, and uh, they overheard our discussion of this problem and one of the guy, his name is Shrikant, he approached and he said, um, you guys are trying something like this and I just overheard it and mm, have you heard something about Hadoop? And I had no idea what is Hadoop. And he said it's an open source, it's free ecosystem, you can try. And then I checked and I realized, okay, that is some interesting technology, just map reduce, and it is something around divide and conquer with many computers there. Seems complicated, but maybe possible. So we started trying, and Hadoop worked. Like it solved the problem the way we wanted. It scaled, and it was pretty stable. And that's where I interacted with data engineering. The relevance of the story here is I was a software engineer. My entire team was software engineer, and we all started working with this tool Hadoop, and then Scoop, then Hive, then Impala, then all this ecosystem. But finally, we all brought from software engineering, and we just started working on a different tool. Like for a backend engineer, front end engineer, you try different tools. That was the reason I said data engineering is actually nothing but a software engineering, but a specialization on data. So that is for me is data engineering, where you specifically work on usually distributed systems and try to solve the massive data problem. So you modern ecosystem, I don't think everybody agree that data engineering is software engineering. There is a specialization on data engineering. There are ETLs on data engineering, some data engineering, SRE infrastructure. So I would say data engineering is a mix of many things now. Other set of data engineers work with the analytics ecosystem. So like heavyweight ETL, building dashboards, running real-time analytics and solving some real business problem or product. So that is heavy on the engineering side, streaming side. So engineering as a landscape is everything. It's start from batch, streaming, ML, AI, infrastructure. I don't know. There are many more. So as a scope, I would say data engineering scope has many dimensions. In data engineering, you may work with databases, even from Postgres to distributed databases, writing heavyweight ETLs, doing transformation, moving data from one to another, and doing this efficiently. Another data engineer can read them, build different kind of transformation pipelines on them, can serve as a real-time structured, real-time streaming team, which read data from some real-time services, and then you uh, consume them and produce it to different ecosystem running on CDC, publish infrastructure side of it, who manages and maintain all this complicated and many different technologies, who work on observability and handling the infrastructure side of it. Then it goes to the machine learning side. A lot of data engineers work very closely with data scientists, where they publish and clean the data, making the model running the production in the real time, or they help data scientists to publish the model on the real time and do a damage control, understanding the model, uh, stop the production services if something goes wrong. So that is one of the another work data engineers are doing. So it is very hard to actually right now say this is exactly data engineer do. Entry bar and hiring bar is very different in different companies and team. It is very proportional to the way a team and company behaves. I mean, some are very heavy on the software engineering part of the data, so they will go on a traditional software engineering interview, data structure, algorithm, system design. Some are very heavy on the SQL and ETL analytics part, so they can focus on very on the SQL based on interview. So, but when it comes to yeah, you can say in a junior position, I will still say it's a software engineering. If you're already experienced in data engineering, then the job and the project and team is a bit different. Some jobs heavily rely on streaming, and maybe you work mostly on the batch. The problem of batch and streaming is really different. So it is not wrong if a team reject a candidate because of this potential that somebody is streaming heavy and this job is batch heavy. Foundation work definitely work, but maybe the team has very ahead in the streaming journey and there everything is streaming. They are streaming as a service. Interview is being a part of machine learning team, so they are called machine learning engineering, but yeah, I mean, it's a data engineering and you can be a machine learning engineering. For that you need to have a good foundation on the machine learning side of it. At least you understand some of the models, you understand what data scientists are talking about. So if you need not to be an expert in mathematics and you should know everything around machine learning, but if you understand or have you if you work with data science team, it is you will understand the pain and you will understand the word and what are the things they are actually desire, and you can build solution out of it. There's a buzzword around MLOps, which is machine learning infrastructure. uh, it works because it has too many kind of different infrastructure technologies. So if you know and work around them, then it is easier to move to the machine learning engineering or data engineering on machine learning side of it. So you need to understand how a model can be deployed, CI/CD on the model, dropping the model, applying the model. If model does something wrong in the or A/B testing, red tape testing, you stop the model, you do the damage control on the modeling side of it. So all these things comes on the deploying side where you need to be heavy. Part of the question will be, is D close to analytics or data science? Well, it's close to nowhere. It sits in the between. If you like, you can move to the analytics part. If you like the machine learning, you can move to the machine learning part. It's just that you need to be uh, work on which part you like and get deeper inside it. There is another part, which is infrastructure part. So it really depends. That's why when I started, I said if you are so if your foundation comes from software engineering, it is just like learning new technology tools and softwares, and then you can move to analytics, data science, infrastructure, something in between. It depends. So you really can go to any of this. You really can't justify it as analytics heavy or data science heavy. It really depends on the team, project, company, group, individual. So this is a hard, like you just can't say, yeah, it is analytics heavy, it is data science heavy. No, this is not. Some technologies to start with data engineering. Well, that is interesting. Some normal technologies is any ETL engines, a data warehouse, databases, Apache Spark, Kafka, Flink. These are some common name which usually get used in all this ecosystem. As a programming language, Python, Scala, Java, SQL is important nowadays because most of the tool is getting no code, low code, or SQL heavy. So if you know SQL, you can avoid the part of writing too much code and be on the SQL side, and then writing programming actually on the more complicated stuff. So that is a good thing actually. And other tech stack is a currently there's a many modern tech stacks. So like uh, the entire data engineering platform is moving slowly, not slowly, I would say very fast toward Kubernetes. So that is one of the ecosystem. It is good to understand. Then many different workflow managers like Airflow, Prefect, Daxter. or Kubeflow or Argo. So it really depends in which kind of stack and cloud interfaces you're using. There are many distributed databases which you can go ahead with. You can work with different kind of query engines like Presto, Trino. You can work with different open data formats like Iceberg, Hoodie, Delta, and then there is other tech stack on the dashboarding side like Apache Superset or Metabase. So we will have a detailed discussion about all these topics in our upcoming community meeting, uh, where we will try to explain all this question in a more broader version and a more broader way, where we will have further discussion with the different members, with the different teams. And so please join us in the discussion. Thank you very much.